Math people, this video lesson is going to focus in on multi-step equations that have a couple special scenarios involved with them, mainly the distributive property, combining like terms. But before we get to those, I thought it would be helpful just to look at a plain old two-step equation, a multi-step equation. It has more than one step involved. So here we've got 2x plus 3 equals 17. The important thing to remember is I've got two things. I've got multiplication, 2 times x, and I've got addition, plus 3. Which thing do I inverse first? When we solve equations, we use inverse operations. So in a normal problem where I'm not solving for x, where I'm just doing math, like 3 plus, in parentheses, 4 minus 1 squared, I don't know, times 16. When I'm doing this problem, I use PEMDAS, the order of operations. Parentheses, then exponents, then multiplication and division, followed by addition and subtraction. However, we aren't just doing math right now. We are using inverse operations to peel this problem apart algebraically to figure out what x equals. So instead of going through my normal order of operations, which is parentheses, exponents, multiplication, division, addition, subtraction, I am instead going to go in the inverse order to peel the problem apart. So the first thing I'm going to look for is there any addition or subtraction? Which there is. I'm going to undo the addition first. Whatever you do to one side of the equation, you do to the other side. Inverse operations cancel out, so I'm left with 2x equals 14. 17 minus 3 is 14. And then my last inverse operation is I'm going to divide by 2 because that's the inverse of multiplying by 2. Whatever you do to one side of the equation, you do to the other, so you're left with your solution, x equals 7. This is using algebra to solve for a variable. Now, we've done this. We're now going to go to some beefier examples. I'm going to call these special cases for multi-step equations. Sometimes you have to do more than just inverse operations. Thing one to consider is if you see a problem that has the distributive property, we've talked about this in chapters prior. If you have a problem that has distributive property, please take care of the distributive property before you go solving the problem. So to take care of the distributive property means that I need to multiply 5 by everything that's in the parentheses. This problem is 5 times x minus 2, the whole quantity. So that's 5 times x and 5 times 2. So I could rewrite this equation as 5x, 5 times x, minus 10, which comes from multiplying 5 by 2. And now I can treat this problem just like I did the one on the slide that we looked at before. I'm going to look at PEMDAS, and I'm going to go backwards through it to peel the problem apart. I'm going to look at addition and subtraction first, and then I'm going to finish the problem off quite simply by dividing by 5, and I'll get my answer of 4. But the way that we got there is by first, before we tried to do anything else, we tried to simplify this equation by using the distributive property. What that does for us is it gets rid of the parentheses and it makes the problem look a little bit simpler to work with. If you ever have an opportunity to get rid of parentheses, do it. And one way to get rid of parentheses is by using the distributive property in a scenario like this, where you have a number being multiplied by something that's in parentheses. All right, so that's special case number 1. Special case number 2 is sometimes you might have an opportunity to use the distributive property. Sometimes you might have an ability to simplify an equation by combining like terms. In this equation here, I have like terms that are both on the same side of the equal sign. 3x plus 4x, hey, those both have an x in them. This and this, they're like terms. I can combine them. I can add them together. 3x plus 4x is 7x. So I could rewrite this equation. Instead of 3x plus 4x equals 35, I can combine those things into one term that's 7x. And now this is a nice one-step equation. I can just divide both sides by 7, and that gives me an answer of x equals 5. So getting the answer, not too bad, but look at what we could do before we even try to solve. We can combine like terms, simplify the equation, make it a little easier on ourselves. Let's look at another one of those in this number 4 here. This is the same concept as number 3. I have two terms that have a y. So I've got 5y and 1y, minus 1y. So these two terms, those can be combined together. They're on the same side of the equation. They're both on the left side of the equal sign. So why not, like we did a chapter before, combine like terms? 5y minus 1y, I can rewrite that as 4y. So now the equation is 4y plus 6 equals 14. And hey, now it's just a nice two-step equation. We can do this. So we're going to subtract 6 from both sides. Boom. And rewrite this as 4y equals 8. We're going to divide by 4. And divide by 4. And we're left with our solution, y equals 2. But who cares about the answer right now? The bigger thing to consider here is when you have two terms that are like terms, combine them and then do your inverse operations. Then peel the problem apart and get your solution. So this is the added little extra skill. So I oftentimes, you don't have to use this, but make yourself a little checklist for solving equations. Number 1, look for distributive property. If there's distributive property, take care of it before you start solving. Number 2, you might have distributive property, you might not. But that's the first thing to look for. The next thing you should look for are there like terms that I can combine together? You might have some, you might not, but make yourself a little checklist. You should look for these next. And then lastly, step 3 would just be solve using inverse operations, which let's do one more example and we'll use our little checklist here. Solve using inverse operations. All right, so you might have these first two things. I'll put a little star by them. You might have those, you might not, but look for them first. And once you've looked for those things, lastly, go ahead and solve. In this green number 5 problem here, I think I have both of these things. So first I'm looking for distributive property, which plain as day, it's the first part of the equation, 3 multiplied by x plus 4. So I can rewrite this problem as 3x plus 12 plus 5x equals 32. The only thing that changed from line 1 of the equation to the second line that I've written is I've distributed. 3 times x is 3x, 3 times 4 is 12. And then I just rewrote the rest of the equation and check, did the first thing. Now I'm going to look for like terms. Maybe there are some, maybe there are not. I can see that there definitely are. 3x plus 5x, we always read from left to right. Those two things can be combined together. So I could rewrite this as 8x plus 12 equals 32. All right, and now it's a nice two-stepper. I can do this easily. We've been doing these problems. You can do them in your sleep, maybe by now. Solve using inverse operations. So I'm going to subtract first. Rewrite this as 8x equals 20. And then to finish it off, divide both sides by 8. So divided by 8, divided by 8. And I'm left with x equals 20 divided by 8, which you could read as a fraction, 20/8. 8 can go into 22 times with 4 left over. So 20 over 8 can be rewritten as 2 4/8, or if you simplify that, 2 1/2. And I know that some of you will actually prefer to do the long division. I've told you in class before, I'm not a big long division person if I don't have to. I'd rather just leave it as a fraction. But if you did do this division, you'd get the same answer. You'd get 2.5. 8 can go into 22 times. Subtract, add a decimal and a 0, bring the 0 down. 8 can go into 45 times evenly, so 2.5. So whether you write it as a decimal or a fraction, that's up to you. But anyways, here's your mini lesson on the extra problems that have 2 steps and a little bit extra. And one last reminder, use the checklist. It might help you. Write it down. Look for distributive property first. You might have it, you might not. Look for like terms that you can combine. You might have some, you might not. And then once you've done all those things, go forth and solve using inverse operations. Do good things mathematically. And if you have questions, let me know. Otherwise, toodles.